Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides, because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the 4th term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3. Just keep going till you get to 39. Or we can do the method we've just done, which is solving it. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440, because we're told in the question that the perimeter is 440. So put our lines in, because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card. is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to two decimal places will be 5.40. Whenever you have a one-digit number or a one decimal place number, but you're asked to round it to two decimal places, you should really put a 0 on the end, which is what we've done. So we're going to start by doing a multiplication grid. And we're multiplying the x minus 11, so x and minus 11, by the x minus 3, so x and then minus 3. So x times x is x squared, x times minus 11 is minus 11x, x times minus 3 is minus 3x, and minus 3 times minus 11 is positive 33 because two minuses make a plus. Put the terms together, and you'll notice here that we can simplify. So we've got two x terms, so we can collect the x terms, and that will give us x squared, minus 14x plus 33. So our answer is x squared minus 14x plus 33. So here we can just draw in two extra lines and we can see that it makes a right angled triangle. And we're asked to find the length of the line segment AB. So we're asked to find what this length here is going to be. And we know what the other lengths are. We know that this is 2 and this is 3. So we're going to be using Pythagoras. In Pythagoras, we start by labelling the sides A, B, and C must be the one that's opposite the right angle. And so we know Pythagoras is A squared plus B squared equals C squared. A is 2, B is 3, and 2 squared plus 3 squared is going to be 13. And then we're just going to solve that by square rooting both sides. So the square root of 13 is 3.605 blah blah blah. And it asks it to 2 decimal places, so it's going to be 3.61. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H, and A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half A plus B H. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So the first thing we need to do is we need to solve the inequality. So I'm just going to write out again just so we've got a bit more space. And let's put our tram lines in. So the first thing I'm going to do is get rid of that -2. So we're going to add 2 to all 3 sides. So that'd be 29, 6x, and then 57. Okay, the next thing we're going to do is we're going to divide by 6 all 3 sides, so we get x on its own. That's what solve means, just get x on its own. So that leaves us with a horrible number, 4.833 blah blah blah. X in the middle, and then we've got, I think, 9.5. Okay, now we're asked to find the integer values. Integers are just whole numbers. So we're thinking about what are the numbers between 4.833 blah 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 and 9.5. Well, it can equal 4.833, but actually it can't because we're looking for integer values, which are whole numbers. So the first whole number is 5, then 6, 7, 8, and then 9, because it's less than 9.5, not less than 9, but it can't be 10 because 10 is more than 9.5. So we notice with the simultaneous equations here, the coefficients of the x and the y's are different. So we need to make either the x is the same or the y is the same. I'm going to pick the y's. So we've got a +3 here and a +5 there. And so we need to find the lowest common multiple of 3 and 5, which is 15. So we need to make them both 15. So I'm going to write out the first equation again. And go get my lines in. Because I'm going to times everything by 5 to make the coefficient of the y to be 15, because that's what we've decided to do. So we've got 10x plus 15y equals 40. And we're going to do exactly the same thing with the second equation. So we've got 3x plus 5y equals 14. Get our lines in. This time we're going to times everything by 3, because 5 times 3 is 15. So that's going to be 9x plus 15y equals, and then 14 times 3, which is 42. And so we're going to write the equations next to each other so we can do our simultaneous equation magic on them. So we've got 9x plus 15y equals 42. So we're going to draw our circles in. And remember, simultaneous equations are always working downwards. So we draw these circles in just to show which direction we're going. And we're looking at the signs of the y. And the reason we're looking at the signs of the y is because the y is the one with the same coefficient. Now, with these signs, if they are both the same, we subtract. If they are both different, we add. Now, looking at them, they are both pluses, so they are the same, so we are going to subtract. And we don't just subtract these, we subtract all of them. So we're going to do 10x take away 9x, which is just x, 15y take away 15y, which is nothing, which is good, that's what we want, and 40 take away 42, which is going to be -2. So x is equal to -2, but that is only one of the battles because we need to find out what y is. So we're going to substitute in that -2 into our first equation. So we've got 2 times -2 plus 3y equals 8. And we can get our lines in. So first thing we're going to do is take away the minus 4. We're going to add 4 both sides because we've got a minus 4 here. So we're going to add 4 to both sides. So we've got 3y equals 12. And then the next thing is we're going to divide by 3 both sides to get y equals. So y equals 4. And we can check that by substituting it into the second equation and doing 3 times minus 2 plus 5 times 4, and that does equal 14. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. With these questions, it's normally easier to view these as 2 separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay. Now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. The way you do this question is very, very similar to if it was 1/5 minus 1/6. You need to get the denominators to be the same, and then you add or subtract the tops. Well, be subtract in this instance. So 5 and 6, the lowest common multiple of 5 and 6 is 30. So I'm going to times the left-hand side, top and bottom, by 6, and the right-hand side, top and bottom, by 5. So times the top and bottom of the first one by 6, you get 6x over 30. Times the top and bottom of the second one by 5, you get 5x also over 30. And when you've got a common denominator, you just subtract the tops. So it will be x over 30. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value. So 10 plus 25 is 35. Then we add the next value. So that's going to be 50. Now, the cumulative frequency is the total amount so far. So for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So we plot it at the 20. So it'd be 20 and then 10. So this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. Okay, so we're asked to find length AB, which is this length here. But I'm going to start just by renaming these letters, and I'm going to put this as a capital C and this as a capital A and a lowercase a over here. And the reason it being is that we're going to use this formula, which is area equals half AB sine C. And you can see that the angle C is a C in this formula, and so I've just changed it to a C here. And so we're looking for little a. We're not interested in little c or big B or big A. We're focused on, and we've got a little b here, we're focused on little b, little a and big C. The area is given to us in the question is 21.6. And we're looking for A, but B is 5 and C is 68. And so all we need to do here is rearrange all of this. And we're going to start just by working out what half times 5 times sine 68 is. And that's going to be 2.317 blah blah blah. That's times A. And then we're going to do a bit of solving, because if we divide both sides by that 2.317 blah blah blah, that'll give us what A is. So when we do that, we get 9.318 blah 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 equals A. So rounded to 2 decimal places, that's going to be 2.32. I'm going to start off by labelling this triangle. So we've got a big A, big B, big C, and the opposite ones are little a, little b, and little c. And we've got to figure out whether we're using the cosine rule, sine rule, or something else. We've got 3 lengths, and we're looking for an angle. So whenever we've got 3 lengths and an angle involved in the question, it's definitely going to be the cosine rule. And we've got to figure out which of the cosine rules we're using, because there's 2 variants, one when you're looking for a length and one when you're looking for an angle. And we're clearly here looking for an angle. So the cosine rule I'm going to use is cos A equals b squared plus c squared minus a squared over 2bc. And all that is, if you don't know what this formula is, it's just a rearranged variant of the a squared equals. So it's just rearranged, and it helps if you remember both of the formulas for the cosine rule. It does make things a bit easier. So we're going to write it again, but this time with all of the numbers and letters in that are in the question. So instead of b squared, we've got 9 squared plus, and then the c squared is 6 squared minus the 4 squared over 2 times b, which is 9, times c, which is 6. And when you do that on the calculator, you get 0.935 blah blah blah, but that's what cos x equals. So if we try and solve that now, all we need to do to both sides is the inverse cos. So we're just going to do the inverse cos of 0.935 etc. that's on the calculator, and that gives us 20.741 blah blah blah, and it says it wants it to 2 decimal places, so that's going to be 20.74. We're going to work out what the function fg is first, and functions actually queue up, so the first function will be g and then f. So we're going to first of all look at the function g, which will be 3x minus 3, and so it will be f of 3x minus 3. Okay, so all I've done there is fed in the x, which is inside the brackets, into the function g, and when you feed it in, it just becomes 3x minus 3, and it's even the same letter. Next, we want to feed in the 3x minus 3 into f of x, so where this x is here. So it's going to be 5 times 3x minus 3. Now the question actually has this equal to 30 and asked us to solve it. So we're going to get that equal to 30, so 5 brackets 3x minus 3 equals 30. So we're going to get our solving lines in. Okay, we're going to start off by actually dividing the 5 both sides. We don't need to expand the brackets, we can actually just get rid of it by dividing the 5. And that will give us 6. I'm going to add 3 to both sides to get rid of that minus 3. And that will give us 3x on the left hand side and 9 on the right hand side. Then we're going to divide by 3 to get rid of that 3 before the x. So it just becomes x equals 3. So answer is 3. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%. So we're going to take away the 8.1%. And then when we do that, we get 91.9%. Make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100, okay? And what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory. And it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate. And we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360. Take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should re-put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. When solving simultaneous equations, when you have the equations drawn graphically, the solutions are just where the two lines cross. So we've got a solution here and a solution here. So the first solution is that x is 0 when y is minus 3, and our second solution is that x is 3 when y equals 0. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already. We know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared, so we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6, 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. With this question, we're going to first of all have to find a length before we can find the length AF. And it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of A squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117, and then we just get our solving bit in. just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angle triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. So the first thing to do is we want to find the roots from the sketch that we've got. And the roots are just where the graph crosses the x-axis. So we can see it crosses it here at -8, crosses it here at 3, crosses it here at 5. Now, what is special about roots? Well, roots are where the graph equals 0. It's where y is 0. And the only way to get to 0 is, for looking at this, is if one of these brackets is 0. So we're going to say, okay, well, let's have a look at the first one, x plus a. Let's get that equal to 0. Oh, equal to 0. So we're going to put in the first root in there. We're going to say -8 plus a equals 0. Add 8 both sides. A must equal 8. So if a equals 8, then the whole thing will equal 0. That's the first root done. Going to do the same with the next one. X plus b equals 0. And this time the root is 3, so it's going to be 3 plus b equals 0. Take away 3 both sides, and you get b is -3. Then we're looking at the last one, x plus c. Look at the last root, which is 5. Oh, we're going to get it equal to 0, and then it's going to be 5 plus c equals 0. And take away 5 both sides, you get -5. And so if a is 8, b is -3 and c is -5, it means that at -8, 3 and 5 it will equal 0, which is what it does in our graph. Now you might say, well, why does a have to equal 8? Why can't b equal 8? It can. These can be in any order, and so if I wrote these in the opposite order, -5, 8 and -3 for instance, it would still be correct. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2. And then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.